Ladies and gentlemen, thank you very much for your answers. To save time, let's get into this question. It says here a pulley system with a mass piece is operated by an electric motor. It is used to lift up a load of 120 in an upward direction with a constant speed as shown in the diagram below. Load covers a distance of 6.8 meters in 0.1 seconds. So we are given delta y, which is just now equals to 6.8 meters. And then we also have t, which is 0.01 second. At 5.1, it's an easy one. Define power. 5.1, define power. Power is defined as the rate at which work is done, and that is now your 2 marks. The rate at which work is done. Easy, 2 marks. Remember, it is a definition, so 2 or 0. Now at 5.2, calculate the work done by gravitational force on the load, ladies and gentlemen. So let's check how many forces do we have that are actually acting on the load. So when I look at the load, I'm going to have this force here, which will be now force of tension, or maybe we can call it force that is due to the mass piece. Force due to the mass piece. And then we are going to have now this force also, which is Fw, which is now just equals to mg. So the examiner is direct to say the work done by the gravitational force. So when we want to calculate work done by Fw, is just now Fw multiplied by x cos now of theta, and this will be just mg, which is 125 multiply now by 9.8 multiply by 6.8. Now comes the biggest challenge here. Is it now going to be a cos of 180 or cos of 0? We said it will be now cos of 180. Why? Because now Fw, remember the motion is upward, so Fw is actually acting in an opposite direction with now what? With the direction of the motion. Therefore, our final answer will be negative 88330 joules, and this is now how we get our 3 marks. But what was the catch here? The catch was us actually identifying the forces that are actually doing work here. So I'm still going to use the very same free body diagram for me to actually understand now question 5.3. Why? Because even if now I look into this mass piece, I will have Fw of the mass piece, and I will still have Ft also from this 125 kg block. So it basically says when I look into this, Ft of the mass piece must actually be equals to the Ft of the load. Why? Because if they are not equal, it means the strain will now be cut into two pieces. So it basically says regardless of what I do, but if I want now to calculate this second force, which is now Ft, I will definitely need now to work with the free body diagram that is given. The reason why I need this free body diagram is because the question says calculate the average power. So the average power needs now us to get P, which is equals to W over changing T. So it means I will need now to calculate the work that is done by the electric motor. So it means I must now say work net is actually equals to change in EK. Before I get maybe to that, let me calculate each work done separately. So I'm going to calculate now the work done by Ft, which is now the load of the mass piece. This will just be Ft or Fwt of the motor, W of the motor, multiply by x cos now of theta, and this becomes now 100 multiply by 6.8 and then cos of 0. I forgot now to add another 9.8. Let's add 9.8 multiply now by 6.8 and then cos of 0, and this will give us something like 6664 joules. But we are not done yet. We also need now to find work net, which is equals to changing EK. But we are told an important information that it is traveling at constant speed. And traveling at constant speed, what does it mean? It means we do not have a change in velocity. Remember, V final minus V initial is actually our change in velocity. So we do not have that. Hence we say now EK is just equals to 0. But which forces are doing work here? We have now a force of the motor plus the work done by Fw of the load plus work done by Fw of now the mass piece, and all this must be now equals to 0. Immediately thereafter, one can say work done by the motor is plus 6664 minus 8330, which is equals to 0, and then work done by the motor is equals to 1666 joules. But now this is the work done by the motor. It is not the average power. So for us to get average power, we will need now this equation to say now we have 1666 divided now by 0.01, and our final answer will be something like 166,6 watts. Input, Mr. Sarami.
No, sir, I understand, sir.
Thank you very much. Onasithole.
I also understand, sir, and I see my mistakes. Thank you, sir.
Thank you very much. Onasithole. Thank you very much. Ladies and gentlemen, this was just now work, energy, and power. Just as a reminder for us as to what needs to be done. So this question, it incorporates the basics of work energy as well as now power. You use the equation, and remember the equations will be given, and this one here is our energy theorem. Hence I said I don't want now to give you a lot of information. Energy, work energy theorem. Work energy theorem. So I don't want now to give you a lot of things. Hence the relation of work was done earlier. Ladies and gentlemen, here is a question that I have. I will give you just a maximum of 10 minutes for us to be able also to finish exactly at 7:30. Ladies and gentlemen, thank you very much for your answers. This one was quite doable and easy. Most of us we got it right. Just note the SI units on your final answer. It's very important, because we will be losing marks unnecessarily because of not having the correct SI units. Ladies and gentlemen, let's get straight into it without wasting any time. At 9.1, the diagrams below show two types of generators, diagram X and Y. Write down the energy conversion that takes place in a generator. So this is just a direct question for generators. So we know that it's mechanical energy from mechanical energy to electrical energy, and this is just now 1 mark. Write down the type of generator represented by X and represented by Y. 921 and 922. Let's check now X. When I look at X, it has split rings here, ladies and gentlemen. Split rings. And when I look now at Y, it has slip rings. So we already know that slip rings are associated now with AC, and then split rings are associated with DC. So it is easy now for one to easily say this will be a DC generator, and then this one will be an AC generator. The examiner did not necessarily say write down the abbreviation, but I prefer writing direct current generator. I am not sure if they will penalize you for writing DC, but for me I prefer writing everything in full. Alternating generator, alternating current generator, and then this is just now 1 mark, and then at 9.3 the examiner says state the difference between the two generators by referring to the components that are given. So in DC is because we have split ring commutator, and then in AC we have slip rings. It is just that, but when you look into it, this is just a repetition of 921 and 922, because for you to actually get 921 and 922 correct, you must understand the difference in the components. Ladies and gentlemen, at 941 the examiner says define in words the term RMS voltage. This is just now the AC potential, difference, which dissipates, the same amount of energy, SN equivalent DC potential difference, and remember, ladies and gentlemen, this is now also a definition, so this is now also true or 0. Now calculate 942, calculate the maximum potential difference of the generator. We are given now the root mean square, which is now 220. So it is easy to say V RMS is equals to V max divided now by the square root of 2. This will be now 220, and we are looking for V max and then square root of 2, and then we finally get our V max, which is equals to 3113 volts. So this is now easy. Just remember your SI units at all times. Now they want us to draw the graph which will represent Y, ladies and gentlemen. So because Y it's now an alternating current, I already know that Y then means I must have my axis, and then it must actually now be a sine wave. So it will start from 0, move until it reaches maximum, drops, change direction, and go back now to the starting point. But the examiner says indicate the RMS value. So Vmax we calculated now is 331,311. That is now our Vmax. Remember, RMS is just now half of what we have, and then this will be 222. That will be now our RMS value, and we just now say this is time, and this is now the potential difference. Ladies and gentlemen, this is basically it with now our generators. Remember, this question is focusing on the generator. Also be on the lookout now for the motors as well. From me to you, ladies and gentlemen, thank you very much for your time. Thank you very much for all the efforts that you are putting in, and all the best for the exam that is coming. Feel free, if you have anything that you might need between today and tomorrow relating to paper 1, I will try my level best to assist you one-on-one. And remember, I'm going to send now a schedule for our paper 2 revision. That will be Friday, Saturday, and a little bit of Sunday, even though I know Sundays are a very complex day, but we will try to squeeze something, even if it's just for an hour. Ladies and gentlemen, from me to you, thank you very much, and have a lovely evening.